Productivity. So why do we care about productivity? To be frank, hardware has gotten so fast and so inexpensive over 5 or 6 decades that we're writing more and more sophisticated software to be able to take advantage of that hardware, right? All of those hundreds of thousands of servers. So in order to write software at that level of complexity, we need to be able to write it more productively. Right? People used to write stuff in basically bare machine language and assembly language. You wouldn't think of writing something like a web-facing app in assembly language. Or if you do, you're some sort of masochist. So what have we done instead to make the job of software writers more productive so that we can get more functionality in software with less grungy work? So there's a couple of different productivity mechanisms that we're going to use. Essentially, the 4 that we focus on in this course, one of them is, believe it or not, code that writes other code. There's cases where the code that needs to be generated is based on some sort of a template, and we can actually do some code generation in advance, save ourselves a little work. We can also strive to make our code clearer by making it more concise. Anytime that we can say less and do more, we've reduced the cognitive load on the person who's going to read our code. If they can look at a few lines of code and get the basic idea of what's supposed to be going on, because we're using concise notation, remember when who are you writing code for? You're writing it for like the you of 6 months from now when you come back to your code and try to remember what were you thinking when you wrote it. So one way to do that is try to achieve as much clarity as possible, and one way to achieve clarity is make the notation concise and clean. I'll give an example. Reuse. We all know that reuse is like the holy grail of software, right? Don't do work that someone has already done. Now, in some sense, that is easier said than done, and one of the challenges when we start talking about refactoring is you identify that there are places in your app where you essentially have nearly duplicate code because you're trying to do almost the same thing. And the trick is, can you extract the common part, reuse it, and now you've eliminated the cognitive load of understanding code in 2 different places. So what are the different mechanisms of reuse that we're going to see? And finally, automation and tools. Automation is so your friend. Roughly everything we're going to do in terms of code maintenance, maintaining our databases, deploying the app, running our tests, every one of those is going to be like a one-line thing. Because if you do something manually, it means you could screw it up by doing differently 2 different times by accident. But if you have a script that does the thing, the script is guaranteed to always try to do it the same way every time. And determinism is so your friend. So let's talk about the first couple of these. Code that writes code. The first example of this that we were able to find is something called bitblit. It's a way of passing a mask over an image, and on each pixel, you do some operation that is a function of the surrounding pixels. And in early implementations, it turned out that the way you would code this is you would have like nested for loops to go across a grid and down the columns. And the interior of the loop was switch one, depending on one of the 8 possible values of this thing, you're either doing an XOR or an AND, or you're replacing one value with another. So it's like you've got nested loops, and in the interior of the nested loops, you've got a conditional. But somebody had the bright idea of like, well, OK, let's say that the thing we want to do in the interior of the loops is an XOR. What we're going to do is at runtime, we will generate a version of the code that hardwires the XOR operation, and we'll run just that little version of the code. So you essentially generate code at runtime that does the special case. You run the code, which now has no conditional in the middle, and it runs way faster. So there are variations of this that we're going to see. They're all over the place in Ruby, places that generate code to fit the situation and then throw it away. There's also things like templated code generators. We're going to see some examples in Rails where there are certain types of operations, like modifying your database, where there's some amount of boilerplate code that you have to start from. And even though it's not much boilerplate code, it's really nice that you don't actually have to type any of it, because there's a generator that says, give me the template for modifying the database, but then instantiate the template with these specific sets of things to do, which I'm going to fill in. Okay, so that's a code generator. If anybody's ever used flash fill in Excel, this is the thing where you've got like the first name in a column, the last name in a column, and then you're manually creating a column where you're putting first and last name together. And once you've done 2 or 3 examples, Excel like magically figures out what you're doing, and it offers to do the rest of them for you. Does anybody use this feature? This is an example of program synthesis, where you're basically trying to infer a small program that appears to be consistent with everything the user does. So we're not going to talk about it too much in this class, but it's another example of how do you avoid manually writing code if there's any other choice, right? So you could have the code generated from templates, Or you could have an algorithm that tries to infer a short program that actually does that specific task. So those are a few examples of generators in code synthesis. And if you're following along in the textbook, anytime you see that icon, it's here is an example of where code generation is hopefully saving you a little bit of effort. What about clarity via conciseness? We already know that higher level languages give you more expressive ways to essentially do more functionality in fewer lines of code compared to things like assembly language. We've long ago left behind manual memory management. The percentage of bugs and security holes that are due to poor memory management is now such that you really need to defend your choice of using a language like C. When we talk about Ruby's mechanisms for reflection and metaprogramming, including, if we have time today, we'll get to talk about one of them, as another way of using a higher level of abstraction to express a task. But even in something as simple as syntax, sometimes you can make simple syntactic choices that reduce your cognitive load by just a little bit. So, for example, one of the Ruby testing tools we're going to use, instead of writing something like assert greater than or equal to a comma 7, you can actually write expect a to be greater than or equal to 7. Now, you might look at this and say, OK, that's not rocket science. You're just sort of inventing a slightly nicer, slightly more readable syntax. But if you're reading a lot of test code, the amount of effort that it saves you each time really adds up fast. Being able to just look at the code and seeing, OK, it's pretty clear what this line of the test is trying to check. Every little bit helps. So I think the Ruby community in particular is very, very, they place a lot of value on beautiful code that makes its intent as clear as possible. I know most of you have not done Ruby before, but you're also going to see constructs like this, where if you have an equation where you want to find out, for example, what time was it, what does this mean? The current time, OK, I get that part, but what's going on here? Oh, OK, so 60 minutes are in an hour, 60 seconds are in a minute. So this must be like a way of calculating 2 hours. So this expression must have something to do with calculating what time it was 2 hours ago. Or in Ruby, you can actually just write that. Okay, and we'll see why that works. And again, some people look at that and say, oh yeah, that's really cute. It's like a neat trick. But it's more than a neat trick. It's a way of saying, like, when you look at this, it's pretty darn clear what the programmer's intent is, right? And that is the goal, giving you a way to write something that makes your intent as clear as possible. What about the conciseness part? Here is some code that I actually found on a real website. I don't know if people remember the fiasco when the Obamacare website first went up. It had this horrible, horrible experience. Like the website didn't work, and it went down, and it had poor availability. So in this class, we had a special session investigating what made it so bad. And here's some actual JavaScript code that we found. This is code that, like, if somebody who was taking their first programming class wrote it, I'd be like, OK, I get it. But this is code that appeared in a website that millions of people are supposed to use. Why, in God's name, wouldn't you write something like this? Even if you don't know Ruby, you should be able to read that. Right? In fact, even if you don't know that between is actually a function in Ruby, it's pretty clear what it does. Right? So it's like, here's a good test. Can you read the code? If index is between 0 and 4, then A, B, C, D, E, substring whatever the index is. Otherwise, nothing. Right? So again, it's a way of asking, when I read this code 6 months from now, am I going to understand what I had in mind? Now, let me ask a controversial question about this very example. Understanding that most people don't know Ruby, and that's cool. Let me walk you through this example because I want to ask you a question about it. And here it is. Okay? At the top in red is the exact same thing I just showed. Underneath it is a different version of the expression. In the bottom version, you see that there's no checking about the value of index. Index could have any numeric value. Let's say we can assume it's an integer, but we have no idea if it's between 0 and 4. It might not even be positive. Now, I'm going to tell you, as a matter of definition, that in Ruby, if you make reference to an array subscript for which there is no defined value, Ruby will silently return nil. So it's not an error in Ruby to dereference an array index that has never been initialized. So in some sense, it doesn't matter what the value of index is. If index is 1,000,000, then ABCDE subindex will be nil. I will also tell you that the function to_s is toString. So it will return a string representation of whatever you're calling it on, which means if ABCDE subindex is nil, because index is some crazy value, the string representation of nil happens to be the empty string. So I'm telling you that functionally, the bottom one and the top one will have the same effect. They will both do the right thing, whatever the numeric value of index is. Here's my question. But did people understand that before I asked the question? Are we clear on what the stakes are? Great, that was the setup. That was the exposition. Now we go to the conflict. If we're going for clarity via conciseness, which version, if you're writing this code, which version would you use? Or, is either version sort of, equally good and it's kind of more of a matter of taste? And we're going to do the same thing as before. We're going to vote first, and then we're going to turn to a different person than the person you talked to before, discuss your answer, and then we're going to vote again. Isn't that fun? Take some time to think. Think on your own, but this is not talking time. This is thinking time. This is the time when you think internally. That means we are talking to ourselves, or maybe not at all. I'm pretty sure the answer is yes. Do strings behave the same as arrays, that if you reference a non-existent subscript, you just get back the empty string? I'm sorry? I won't swear to the answer, but I will tell you that the answer to that question should not necessarily influence your answer to this question. OK, so let's see what the voting says so far. Here's the votes. So far, the voting is slightly more people think that the first version is preferable, but it's not like a definitive. I should do the thing where I stop the votes, right? OK, so now turn to someone who is different from whoever you talked to before. Talk to them about your answer for like 30 seconds, and then we'll see if that changes any of the results or not. And then we'll discuss it as a group. Whoops, sorry. OK, so voting is open if you want to re-vote. Again, you could vote for the same thing again. You could vote for a different answer, but vote for something. Remember, this is all about participation and having you all discuss this. So that you get the right answer is not the point. Having said that, we'll see if there's convergence on what people think the right answer is. So vote. We're still waiting for like half the votes. We're waiting for 20 more votes. We're waiting for 15 more votes. OK, last few, unless people left. Get them in. 3, 2, 1. All right, let's see what happens. If we re-show. Oh. Very little change. All right, we're going to. Who is willing to argue for one or the other? Anybody want to champion one or the other position? Go ahead. Which one do you want to champion?
For A.
So the top one.
Yeah, the top one's more human readable. And if you, for example, forget the intricacies that the string representation of nil is like an empty string, then you might not know exactly what this means.
So because I'm on the mic, and sorry, what's your name?
Rebecca.
And I'm on the mic and Rebecca is not, so I will repeat, and I hope I paraphrase what you said. The argument is that the top version is probably better because in the bottom version, you have to know that, for example, you'll get nil if you dereference a non-existent array, and you have to know that if you then take nil and try to convert it into a string, you'll get the empty string. So even though in some of these questions there's, quote, no right answer, I am going to come down on the side of that argument. I happen to know Ruby, and I have been doing Ruby for a long time. So if I looked at the bottom one, I'd be like, oh, but what if index is, oh, right, it's OK. And then 2s, oh, right, you need 2s because of it. So I've already done the work, right? I'm never going to get those 8 seconds back. And if you're new to Ruby and you're looking at that bottom one, you should wonder, like, OK, what if index is out of bounds? Is out of bounds even a thing in Ruby? And what value is it returning that it specifically needs to be converted to a string, given that the thing I'm starting from is already a string? So the bottom one is clever. It saves a few characters. But it is higher cognitive load on the developer. And that's the reason that I would come down on the side of the top one. Shorter is not always better. If it's shorter to the point where you have to sort of do unnecessary work just to understand what's going on, maybe you have gone a bit too far. We could hear another perspective.
Yeah, but what if my coworkers don't think I'm clever?
So if your coworkers are looking at the top one and they're saying, hey, why didn't you do the bottom one, which would obviously have been more clever, here's what I would say to those coworkers, and you are free to use this at any time. Brian Kernighan, anybody? Brian Kernighan? Anybody heard of Brian Kernighan? He's the co-inventor of C, a language you may know. He is also one of the core Unix developers. It's suffice to say, Brian Kernighan, when he talks about code, I listen. Brian Kernighan says, debugging is a much more difficult activity than writing code. I don't think anybody here would really fight him on that. Therefore, if you are as clever as possible when writing code, by definition, you have no cleverness remaining to use when it's time to debug your code, which certainly has bugs. So when writing code, err on the side of something that is simple to implement and simple for coworkers to understand. Up to a certain point, it gets better by getting more compact. But if it gets so compact that you find yourself doing extra work, maybe not so much. You may ask, what does this have to do with software engineering? The world, because you're writing code for the you of 6 months from now, right? And like I said, even as a Ruby developer who's been in this language for a while, I have to sort of take an aside to think about, OK, yeah, I'm convinced that that'll work. And that's not good. Okay? There's no, my taking that time out does not in any way increase the value of the code to me. So matter of taste, but there you go. OK? All right. Awesome. So the other two productivity mechanisms we can talk about are reuse, so how to avoid doing work that someone else maybe has already done, and what's the role of tools. So reuse is pretty straightforward, right? Don't write code unless you're pretty sure there isn't existing code that already does what you need. And as we know, there's a lot of different ways we develop to do this. The simplest one is if you have a function that does something, you call that function from all over the place. That's pretty straightforward. There are libraries, sort of collections of related tasks and functionalities. So reusing a library, for example, for parsing dates and times or doing data arithmetic, saves you from having to do that. We're going to we're going to be using a concept called interfaces or mixins, depending on which language you come from, is a way of reusing behaviors across different classes in object-oriented programming. So a class is a useful abstraction because it sort of collects a group of methods together that do related operations on some well-defined set of data. That's kind of what a class is. But sometimes there are behaviors that you would like to reuse even when the classes are different. What would an example of that be? Well, think about the behavior of sorting a collection of items, right? You could make the strong case that a sorting algorithm, right, whether you choose quicksort or binary something or bubble sort, heaven help us, but the logical act of sorting doesn't really depend on the thing being sorted, whether you're sorting numbers or strings or bank account records. As long as you have a way to compare any two elements of the collection and have them satisfy the triangle inequality, ideally, then the act of sorting doesn't really depend on what the collection types are. And in fact, it shouldn't even depend on what type of a collection it is. For example, if I'm sorting a linear array versus sorting the list of lines in a file versus sorting a list of records coming out of a database, again, the underlying type of the collection is not important. What's important is that the collection has a way to say, I can give you an element at any time. or I can always give you the next element, or I can tell you when you have run out of elements. So behaviors like sorting are actually very general, but the language needs to give you a way to nicely reuse the behaviors, even though the specific classes are different. And in Ruby, that behavior is called a mixin, and when we start doing some kind of idiomatic Ruby next week, you'll start seeing some of it. And later in the course, we're going to talk about design patterns. Design patterns are extremely general because they're not about reusing lines of code, they're about reusing a strategy. For example, the idea that there's a client and there's a server in the web world, and the client is specialized to do certain kinds of things, the server is specialized to do very different kinds of things, and that leads to some choices about, for example, the communication protocol between the client and the server and how we choose to structure it. Every client-server system may have its own code base, but the code bases will all sort of follow some certain patterns because the idea of having these differently specialized entities is common to all of them. So we're going to see a large collection of things like that under the general heading of design patterns. And like most patterns, they only emerge after somebody's done it almost the same way a bunch of times and said, you know, there's actually something more general here that we should pull out. So almost every kind of reuse is at some point somebody said, you know, we did this 5 times and it's almost the same thing each time. Can we abstract out the parts that are the same so that you can sort of wrap the parts that are different and take advantage of the extra work? One of the mottos that I'll be nailing on this a lot is called DRY, for don't repeat yourself. The first mention of this that we know of was from Hunt and Thomas. They said every piece of knowledge in the system has a single unambiguous place where it's represented, which means, for example, you know, if there's the maximum number of users in the system or the maximum length that somebody's name is allowed to be, there's exactly one place that is easy to find, that is obvious, and it's well documented. And as we'll see, with so many of these other things, it is easier said than done. But if you do it, it means that when you have to repair something or when you have to change something, you avoid the problem of having to change it in multiple places and wondering if you got them all right. So what are we going to do in this course that addresses this opportunity? A lot of refactoring. A good deal of refactoring is exactly this. You realize that there's 2 or 3 places in your app where you're doing almost the same thing, and you're sort of doing it kind of half-assed 3 different ways, and you'd like to use your whole ass and do it once and capture the commonality. Centralizing knowledge of housekeeping tasks. So a lot of housekeeping tasks like updating the database, deploying, making sure all your tests run, writing scripts or using tools that help you automate those things so that there's one place to go to say, wait a minute, if the whatever test fails, where do I go to look at the results and find out what happened? And as we'll see, there's tools like Rake in Ruby, the classic make tool that probably everybody has used at some point, build systems like Ant. This is what those tools do, right? They're trying to centralize in one place the knowledge of how to do certain important tasks. Which brings us to tools and automations. Automatic is the way to go. If you do it manually, you probably will not do it exactly the same way every time. That's the reason that tools like Make were invented. They can do things like track dependencies for you and make sure that the steps that need to be done actually get done in the right order. Every tool has a learning curve, and I think one of the most challenging things in software is agreeing that you're going to attack the tool and learn its learning curve, because in the long run, the productivity gain is going to outweigh the effort you took to do that. And I know that there are sometimes when it feels like that day where you cross over seems like it's really far away. But believe me, it is worth sticking to. I would say I learn probably 2 or 3 new tools a year. And it's always because, you know, sort of reading about them and hearing my colleagues talk about them, it's clear that I'm going to get paid back. Right? That I'm going to get paid back because my tests will be more thorough, because I'll get quicker feedback on how my code's doing. So we're going to ask you to learn a lot of tools, and it's a life skill. So I view it as an opportunity. So you're welcome about that. The other nice thing about tools, though, is that unlike a manual procedure, a tool can be instrumented. The tool can keep track of what it's doing. It can record data about what it's doing. So in addition to being able to do the same thing every time, you can track how you're doing. How many bugs did your tool actually find this week compared to last week? Did your test coverage from last week go up, or did it go down, or did it stay the same? How often did somebody take a look at your commit on GitHub before saying, OK, your code looks good, it's ready to merge it? So tools can actually tell you something about how your work is going and how your team's work is going. And in fact, we have some experimental tools we're developing for this class, which you will get to use in your project that we hope will help your team do exactly that. So, you know, the summary is this is a lifetime learning thing. You're going to get to use lots of tools in this course. And it's like learning a language, right? Learning how to learn a tool is a good life skill to have. So we hope that that's something you'll come out of.